Somewhere in the depths of our galaxy, orbiting a distant star, there is a planet where the weather defies everything we know. On Earth, rain falls gently from the sky. On this world, storms rage with unimaginable violence. Powerful winds sweep across the planet at speeds reaching 7,000 kilometers per hour, faster than a bullet. And within those storms, something deadly is carried through the atmosphere. Not water, not ice, but tiny razor-sharp fragments of glass blown sideways through the sky in a relentless cosmic storm. This strange and terrifying world is known as HD 189733b, a planet so extreme that even our most advanced spacecraft could never survive its atmosphere. Tonight on Theories Before Sleep, we explore one of the most dangerous planets ever discovered, a world of violent winds, alien skies, and a storm that never ends. And if you enjoy exploring the mysterious and extreme places hidden across our universe, don't forget to subscribe, because space is far stranger than we ever imagined. In the vast darkness of space, countless planets orbit distant stars. Some are rocky worlds like Earth. Others are giant gas planets larger than Jupiter. Many exist in environments so extreme that they challenge our imagination. Among these strange discoveries is one of the most violent planets ever found, a world where storms rage with unimaginable force, a world where temperatures rise high enough to melt rock, and a world where the atmosphere contains particles that eventually fall as glass. That planet is HD 189733b, located about 64 light-years away from Earth in the constellation Vulpecula. HD 189733b quickly became one of the most studied planets beyond our solar system. But when astronomers first discovered it, they had no idea how extreme it truly was. The beginning of the exoplanet era. For most of human history, planets outside our solar system were purely theoretical. Astronomers assumed they existed, but no one had ever detected one directly. Stars were simply too distant and too bright. Any planet orbiting them would be hidden in the glare of their parent star. This changed in the early 1990s. New observational techniques began revealing subtle movements in distant stars, tiny wobbles caused by the gravitational pull of orbiting planets. These discoveries confirmed what scientists had long suspected. The universe was filled with planets. Some of the earliest discoveries were surprising. Instead of finding solar systems similar to our own, astronomers found planets that defied expectations. Massive gas giants orbiting extremely close to their stars. These planets became known as hot Jupiters. HD 189733b would soon become one of the most famous examples. The star that revealed its planet. The star HD 189733 is relatively close by cosmic standards. It lies about 64 light-years away and is slightly smaller and cooler than our Sun. Because of its proximity to Earth, astronomers had been studying this star for years. In 2005, researchers noticed something unusual. The star's light was periodically dimming. Every few days, the brightness dropped slightly before returning to normal. This phenomenon suggested that something was passing in front of the star, something large. After careful analysis, scientists confirmed that a giant planet was orbiting the star and occasionally crossing between the star and Earth. This type of detection is known as the transit method. Whenever the planet passes in front of its star, it blocks a small fraction of the starlight. By measuring these tiny dips in brightness, astronomers can determine the size and orbit of the planet. That is how HD 189733b was first discovered. A giant planet, extremely close to its star. Once the planet's orbit was measured, astronomers realized something astonishing. HD 189733b was orbiting its star at an extremely close distance. The planet completes an entire orbit in just 2.2 Earth days. For comparison, Mercury, the closest planet to our Sun, takes 88 days to orbit the Sun. This means HD 189733b is far closer to its star than any planet in our solar system. At such a distance, the planet is blasted by intense radiation and heat. Surface temperatures reach over 1,000 degrees Celsius. At these temperatures, metals can melt and minerals can vaporize. This extreme environment transforms the planet's atmosphere into something unlike anything found on Earth. A planet the size of Jupiter. D 189733b is classified as a gas giant. Its size is comparable to Jupiter, the largest planet in our solar system. But despite its similar size, HD 189733b behaves very differently. Jupiter orbits far from the Sun, where temperatures are extremely cold. HD 189733b, on the other hand, is locked in a scorching orbit extremely close to its star. Because of this proximity, the planet is heated to extraordinary temperatures. The intense radiation from its star causes the atmosphere to expand and churn violently, instead of calm cloud layers like those seen on Jupiter. HD 189733b experiences chaotic atmospheric motion. Supersonic winds rip across the planet's skies. Massive storms form and move across the atmosphere with incredible speed. But scientists would not realize just how extreme these conditions were until they began studying the planet more closely. The power of space. Telescopes. Detecting distant planets is only the first step. Understanding them requires far more detailed observations. This is where space telescopes become essential. In the years following the discovery of HD 189733b, astronomers began studying the planet using powerful instruments such as the Hubble Space Telescope. The Hubble telescope can analyze the light passing through a planet's atmosphere during a transit. When starlight filters through the atmosphere, different gases absorb different wavelengths of light. By studying these patterns, scientists can identify the chemical composition of the planet's atmosphere. This technique is known as transmission spectroscopy. Using this method, astronomers began uncovering the strange chemistry of HD 189733b, and what they found was extraordinary. A deep blue planet. One of the most surprising discoveries about HD 189733b was its color. Observations revealed that the planet appears deep blue when viewed in visible light. This immediately caught the attention of scientists. From a distance, the planet looked remarkably similar to Earth. Earth appears blue from space because sunlight reflects off our oceans and is scattered by our atmosphere. But HD 189733b has no oceans. In fact, the planet is far too hot for liquid water to exist anywhere on its surface. So why does it appear blue? The answer lies in the planet's atmosphere. Instead of reflecting sunlight from oceans, the blue color comes from tiny particles suspended in the atmosphere. These particles scatter blue wavelengths of light more effectively than other colors. This phenomenon is similar to the way Earth's sky appears blue. But on HD 189733b, the particles responsible for this effect are not water droplets. They are made of silicates, the same minerals that form sand and glass. These microscopic particles float high in the atmosphere, giving the planet its striking blue appearance. But these particles also play a much more dangerous role in the planet's violent weather systems. Locked in eternal day and night. Another extreme feature of HD 189733b is something known as tidal locking. Because the planet orbits so close to its star, gravitational forces have locked its rotation. One side of the planet always faces the star. The other side remains in permanent darkness. This creates a dramatic temperature difference between the two hemispheres. The day side receives constant stellar radiation and becomes incredibly hot. The night side is cooler, though still far hotter than any environment on Earth. This difference in temperature drives powerful atmospheric circulation. Hot gases rise on the day side and flow toward the night side, where they cool and sink. The result is a planet-wide system of high-speed winds. These winds transport heat around the planet and generate enormous storms. Some of these winds travel faster than 7,000 kilometers per hour. That is more than 5 times the speed of sound. These supersonic winds shape the planet's atmosphere and create the conditions that lead to one of the strangest weather phenomena ever discovered. A world of extreme weather. The atmosphere of HD 189733b is unlike anything found in our solar system. Instead of water clouds, the planet contains clouds made of vaporized minerals. Instead of rain made from liquid water, the planet experiences storms composed of microscopic glass particles. The powerful winds sweeping across the planet accelerate these particles through the atmosphere. When conditions change, the particles begin to fall, but they do not fall gently. They are driven sideways by the intense winds, creating storms of glass that move across the planet at incredible speeds. This phenomenon would eventually make HD 189733b famous among astronomers. But uncovering these details required years of careful observation and analysis. Scientists had to combine data from multiple telescopes and computer simulations to understand the planet's complex atmosphere. What they discovered revealed a world far more violent than anyone expected. A window into alien worlds. HD 189733b quickly became one of the most important planets in exoplanet research. Because the planet transits its star regularly and is relatively close to Earth, it is easier to study than many other exoplanets. This allowed astronomers to gather detailed data about its atmosphere, weather, and structure. Each new observation revealed something surprising. The planet's atmosphere contains exotic chemicals. Its clouds are composed of unusual minerals, and its weather systems operate on a scale far beyond anything seen on Earth. These discoveries provide valuable insight into how planets form and evolve in extreme environments. They also help scientists develop new techniques for studying distant worlds. The methods used to analyze HD 189733b are now being applied to many other exoplanets. Some of these worlds may even have conditions suitable for life. The beginning of a deeper mystery. Although astronomers had already learned a great deal about HD 189733b, many questions remained. How exactly do the planet's extreme winds form? What drives its powerful storms? And how do glass particles form within its atmosphere? Answering these questions would require even more advanced observations. Over the following years, scientists would continue studying the planet using powerful telescopes. With each new discovery, HD 189733b revealed more about its violent and exotic nature, and slowly, astronomers began to understand the full extent of the planet's extraordinary weather. A world where the skies are filled with glass, and where storms rage faster than any winds ever recorded on Earth. When astronomers first confirmed the existence of HD 189733b, they immediately realized that this was no ordinary planet. Its size was enormous, its orbit was incredibly tight, and its environment was far more extreme than anything found in our own solar system. To understand why HD 189733b is so unusual, scientists first had to answer a fundamental question. How could a giant gas planet end up so close to its star? The mystery of the hot Jupiters. In our solar system, the largest planets orbit far from the Sun. Gas giants such as Jupiter and Saturn formed in the cold outer regions of the solar system, where temperatures were low enough for large amounts of gas and ice to accumulate. These distant regions allowed massive planetary cores to grow and capture thick hydrogen and helium atmospheres. But HD 189733b exists in a completely different environment. It orbits extremely close to its star. In fact, the planet is only about 4.6 million kilometers away from the star it circles. For comparison, Mercury, the closest planet to our Sun, stays about 58 million kilometers away. HD 189733b is more than 10 times closer to its star than Mercury is to the Sun. At that distance, the planet is blasted by intense radiation and heat. Temperatures soar well above 1,000 degrees Celsius. Conditions like these should make it impossible for a gas giant to form there. Yet the planet exists. This puzzle led scientists to an important conclusion. HD 189733b probably did not form where it is today. A journey inward. Astronomers believe that HD 189733b likely formed much farther from its star, in a colder region of the planetary system. There, conditions would have been suitable for building a massive gas giant. But something dramatic happened during the early history of the system. After forming, the planet began migrating inward. This process is known as planetary migration. In young star systems, planets interact with a disk of gas and dust that surrounds the newborn star. These interactions can gradually change a planet's orbit. Over time, a giant planet can spiral closer and closer to its star. Eventually, the migration stops, leaving the planet trapped in a tight orbit. That is likely what happened to HD 189733b. It began life as a distant gas giant. Then gravitational forces slowly pulled it inward until it settled into its current orbit. A planet, locked in place. Once, HD 189733b reached its current position. Powerful gravitational forces from its star locked the planet into a state known as tidal locking. This means the same side of the planet always faces the star. One hemisphere experiences constant daylight. The other side remains in eternal night. Tidal locking occurs when gravitational forces synchronize a planet's rotation with its orbital period. The same phenomenon affects Earth's moon. The moon always shows the same face to Earth because its rotation period matches its orbital period. But on HD 189733b, tidal locking creates far more dramatic consequences. The planet's day side becomes intensely hot as it absorbs constant stellar radiation. Meanwhile, the night side receives no direct sunlight at all. This creates a massive temperature difference between the two hemispheres. The birth of supersonic winds. Whenever there is a large temperature difference between two regions of a planet, atmospheric gases begin to move. Hot gases rise, cool gases sink. These movements create winds. On Earth, such temperature differences generate storms and hurricanes. But on HD 189733b, the difference between the day side and night side is enormous. The day side atmosphere can exceed 1,200 degrees Celsius, while the night side is hundreds of degrees cooler. This imbalance drives powerful atmospheric circulation. Superheated gas from the day side rushes toward the night side. As it moves across the planet, it accelerates dramatically. Scientists estimate that the winds on HD 189733b can reach speeds of 7,000 kilometers per hour. That is more than 20 times faster than the most powerful hurricanes ever recorded on Earth. At those speeds, the atmosphere behaves in ways that seem almost unimaginable. Entire cloud systems are carried across the planet in a matter of hours. Storms stretch across thousands of kilometers, and particles suspended in the atmosphere are blasted through the sky at incredible speeds. Clouds, made of minerals. On Earth, clouds form when water vapor condenses into tiny droplets, but HD 189733b is far too hot for water clouds to exist. Instead, its clouds are made of vaporized minerals. Under extreme temperatures, many substances that are solid on Earth become gaseous. Silicates, the same materials that form rocks and sand, can vaporize when heated to sufficiently high temperatures. In the atmosphere of HD 189733b, silicate vapors rise into the upper atmosphere. As they cool slightly, they condense into microscopic particles. These particles form clouds composed of mineral dust. Among these minerals are compounds that can eventually solidify into tiny fragments of glass. These particles float through the planet's atmosphere, carried by the powerful winds sweeping across the planet. And under the right conditions, they begin to fall. The birth of glass rain. The discovery that HD 189733b might experience glass rain came from detailed atmospheric modeling and spectral analysis. By studying how light interacts with the planet's atmosphere, scientists can identify the chemical compounds present. Observations revealed signatures of silicate particles in the atmosphere. These particles behave in ways similar to water droplets in Earth's atmosphere. When temperatures change or when atmospheric currents shift, the particles can condense and begin to fall. But the powerful winds on HD 189733b transform this process into something far more violent. Instead of falling straight down like rain on Earth, the particles are blown sideways at incredible speeds. This creates storms of glass moving horizontally across the planet's atmosphere. These storms can travel thousands of kilometers while carrying razor-sharp particles through the air. Any object caught within such a storm would be blasted by microscopic shards moving faster than many bullets. It is one of the most extreme weather phenomena ever discovered on a planet. A planet that cannot be visited. The environment of HD 189733b is so extreme that no spacecraft could survive there for long. Temperatures are high enough to melt many metals. Winds move faster than any vehicle ever built on Earth, and the atmosphere itself contains particles capable of eroding surfaces through constant bombardment. Even if a probe could reach the planet, it would face enormous challenges. The intense gravity of the gas giant would make entry difficult. The thick atmosphere would create crushing pressures, and the violent storms would likely destroy any fragile instruments. For now, the planet can only be studied from afar. Astronomers rely on telescopes and advanced instruments to observe the light coming from the system. Yet despite these limitations, scientists have learned remarkable details about this distant world. The role of modern space. Observatories. Much of what we know about HD 189733b comes from observations made by powerful space telescopes. Among the most important of these instruments is the Hubble Space Telescope. Hubble has been used to analyze the atmosphere of HD 189733b during planetary transits. When the planet passes in front of its star, a small fraction of the star's light filters through the planet's atmosphere. By studying how different wavelengths of light are absorbed, astronomers can identify the gases and particles present in the atmosphere. This technique allows scientists to determine the chemical composition of distant worlds. For HD 189733b, the results revealed a complex mixture of gases and mineral particles. These findings confirmed that the planet's atmosphere is unlike anything found in our solar system. A laboratory for extreme physics. HD 189733b has become one of the most valuable planets for studying extreme atmospheric physics. Its regular transits make it easier to observe than many other exoplanets, and its dramatic environment provides insight into how atmospheres behave under intense heat and radiation. Scientists use the planet as a natural laboratory. By studying its storms, winds, and atmospheric chemistry, researchers can test theories about planetary climate and atmospheric circulation. These studies help astronomers understand how planets evolve in different environments. They also provide clues about how planetary systems form and change over time. HD 189733b may be an extreme world, but its existence teaches us important lessons about the diversity of planets in the universe. A universe full of strange worlds. Before the discovery of exoplanets, scientists believed that most planetary systems would resemble our own. Small rocky planets near the star, large gas giants farther away. When astronomers first began studying HD 189733b, they expected to find a gas giant with violent weather and extreme temperatures. After all, the planet orbits incredibly close to its parent star, completing a full orbit in just a little more than 2 Earth days. But what scientists eventually discovered went far beyond those expectations. HD 189733b is not simply a hot planet. It is a world where the chemistry of the atmosphere itself becomes extreme, a place where familiar materials behave in unfamiliar ways, and a place where the line between atmosphere, weather, and geology begins to blur. To understand how such a strange environment forms, scientists first had to study the planet's atmosphere in detail. Reading the light of a distant planet, even though HD 189733b lies 64 light-years away, astronomers can still investigate its atmosphere using powerful observational techniques. When the planet passes in front of its star, some of the star's light travels through the thin outer layers of the planet's atmosphere before reaching Earth. Different molecules absorb specific wavelengths of light. By measuring how the starlight changes during this process, scientists can determine which chemicals are present in the atmosphere. This method, known as transmission spectroscopy, has become one of the most powerful tools in modern astronomy. Using this technique, astronomers gathered data with instruments like the Hubble Space Telescope. The results revealed an atmosphere filled with unusual compounds. Water vapor was detected, along with traces of methane and carbon monoxide. But even more interesting were the signs of tiny particles floating high in the atmosphere. These particles were not droplets of water or ice crystals. Instead, they appeared to be made of silicate materials, the same minerals that form sand and glass on Earth. A sky filled with mineral clouds. On Earth, clouds form when water vapor condenses into droplets. These droplets gather together, eventually producing rain. But on HD 189733b, the environment is far too hot for water to exist in liquid form. Instead, the atmosphere contains vaporized rock. At temperatures exceeding 1000 degrees Celsius, many minerals can evaporate and rise into the upper atmosphere. As these vapors cool slightly, they begin forming microscopic particles. These particles create clouds composed of mineral dust. In effect, the planet has rock clouds. These clouds scatter sunlight throughout the atmosphere, giving the planet its deep blue appearance when viewed from space. However, these same clouds also play an important role in the planet's violent weather systems, because once these particles form, they do not remain suspended forever. Eventually, gravity pulls them downward, and when they fall, they do so in an extraordinary way. Supersonic winds, one of the defining characteristics of HD 189733b, is the incredible speed of its atmospheric winds. Because the planet is tidally locked, one side always faces its star, while the other remains in darkness. This permanent day-night divide creates a massive temperature imbalance across the planet. The day side becomes intensely hot. The night side remains cooler, though still extremely warm by Earth standards. Nature attempts to balance this temperature difference. Hot gases from the day side expand and flow toward the night side. Cooler gases return toward the illuminated hemisphere. The result is a powerful circulation system that drives enormous winds across the planet. These winds move at speeds approaching 7,000 kilometers per hour. To put that into perspective, the fastest hurricane winds on Earth reach around 300 kilometers per hour. The winds on HD 189733b are more than 20 times faster. They are fast enough to carry mineral particles through the atmosphere, like microscopic projectiles. And these particles eventually become the planet's most famous feature: glass rain. The formation of glass rain. The atmosphere of HD 189733b contains large quantities of silicate particles. Silicates are compounds made from silicon and oxygen. On Earth, they form common materials such as sand, quartz, and glass. Under the extreme conditions of HD 189733b, silicate materials can exist in vapor form high in the atmosphere. As the gases move toward cooler regions of the planet, the silicates condense into tiny solid grains. These grains become suspended in the planet's clouds. Eventually, the particles grow larger and begin falling toward lower atmospheric layers. But unlike rain on Earth, the falling particles do not drop straight downward. The planet's supersonic winds sweep them sideways at tremendous speeds. Instead of falling gently, the particles streak across the atmosphere, like shards of glass carried by a storm. Imagine a sandstorm powerful enough to throw sharp fragments through the air at the speed of a jet aircraft. That is the environment scientists believe exists on HD 189733b, a world where the atmosphere itself becomes a weapon. Storm systems on a planetary scale. The glass storms of HD 189733b are not isolated events. They are part of a massive global weather system that spans the entire planet. Computer simulations of the planet's atmosphere suggest that enormous storm structures move across the globe. These storms may cover vast portions of the planet's surface. Because the winds travel so quickly, storms can circle the planet in just a few hours. This constant motion makes the atmosphere incredibly dynamic. Clouds form, dissolve, and reform across different regions of the planet. Heat is transported around the globe by powerful atmospheric currents. These processes create a chaotic and constantly shifting climate. From space, the planet might appear calm and blue, but beneath that appearance lies an environment of violent motion. Heat that melts. Rock. Another reason? HD 189733b behaves so differently from Earth is the extreme heat generated by its nearby star. At such close distances, the planet receives enormous amounts of radiation. The day side of the planet is constantly exposed to this energy. Temperatures can rise above 1,000 degrees Celsius. These temperatures are hot enough to melt many metals and vaporize rock. In some regions of the atmosphere, entire minerals can exist as gas. This unusual chemistry allows exotic compounds to form within the planet's clouds. As the gases move toward cooler areas, they condense into particles that eventually become part of the glass rainstorms. In this way, the planet's weather is directly tied to its intense heat. Without the extreme temperatures produced by its close orbit, the glass storms would not exist. A world unlike any in the solar system. Despite decades of exploration within our own solar system, nothing remotely similar to HD 189733b 33b has been found among the planets orbiting our Sun. Gas giants like Jupiter and Saturn possess powerful storms and complex atmospheric systems, but their atmospheres are dominated by hydrogen and helium. Their clouds are composed of ammonia, water ice, and other relatively common compounds. None experience conditions hot enough to vaporize rock, none produce clouds made of mineral particles, and none have winds approaching the extreme speeds observed on HD 189733b. This makes the planet an important example of how diverse planetary environments can be. The universe contains worlds far stranger than anything found in our own neighborhood. Learning from extreme planets. Studying planets like HD 189733b allows scientists to test new theories about atmospheric physics and planetary evolution. Extreme worlds often reveal processes that remain hidden in more moderate environments. For example, the high temperatures on HD 189733b make it easier to observe chemical reactions that would normally occur much more slowly. Similarly, the intense winds provide insights into how atmospheric circulation behaves under extreme pressure and heat. These discoveries help researchers refine their models of planetary atmospheres. The knowledge gained from these studies can then be applied to many other exoplanets. Some of those planets may have conditions far more hospitable than HD 189733b. Understanding extreme environments helps scientists identify which worlds might potentially support life. A planet of beautiful destruction. From a distance, HD 189733b might appear almost serene. Its deep blue color gives it an appearance reminiscent of Earth. But that beauty hides one of the most hostile climates known in the universe. Clouds of mineral dust fill the sky. Supersonic winds race across the planet, and storms of glass sweep through the atmosphere at thousands of kilometers per hour. It is a world shaped by heat, motion, and exotic chemistry, a place where familiar materials behave in extraordinary ways. And yet, despite its violence, HD 189733b has become one of the most valuable laboratories for understanding alien worlds. Because every observation of this strange planet brings astronomers closer to understanding the incredible diversity of planets that fill our galaxy. By the time astronomers began fully analyzing HD 189733b, it had already become clear that this planet was unlike anything in our solar system. Its extreme heat, supersonic winds, and mineral clouds made it one of the most violent environments ever discovered. But one question remained difficult to answer. What does the climate of such a world actually look like? On Earth, meteorologists track storms, temperature patterns, and atmospheric circulation using satellites and weather stations. But HD 189733b lies 64 light-years away, far beyond the reach of probes or spacecraft. Scientists had to find another way, and surprisingly, they succeeded. By carefully analyzing tiny changes in light coming from the planet's system, astronomers managed to create the first global climate maps of this distant world. What they discovered revealed an atmosphere in constant motion. Watching a planet move around its star. One of the most useful features of HD 189733b is its orbit. The planet completes a full revolution around its star every 2.2 Earth days. That means astronomers can observe many full orbits in a relatively short amount of time. As the planet travels around its star, different parts of the planet become visible from Earth. At one point, we see mostly the planet's day side. Later, we see the edge of the atmosphere, and eventually, the night side rotates into view. By measuring how the system's brightness changes during this orbit, scientists can determine how heat is distributed across the planet. This method allowed researchers to estimate the temperature of different regions on HD 189733b. It was the first time scientists had ever mapped the temperature patterns of a planet outside our solar system, a planet that glows with heat. Because HD 189733b is so hot, it emits a large amount of infrared radiation. Infrared light is invisible to human eyes, but can be detected by specialized telescopes. One of the instruments used to observe this radiation was the Spitzer Space Telescope. Spitzer was designed to detect heat signatures from distant objects in space. When astronomers used it to observe HD 189733b, they were able to track how the planet's heat changed as it moved around its star. This revealed something surprising. The hottest region of the planet was not located directly beneath the star. Instead, the hottest area had been shifted eastward. This shift provided direct evidence of the planet's extreme winds. Winds that move entire atmospheres. On Earth, strong winds can push weather systems across continents, but on HD 189733b, winds are powerful enough to move entire atmospheric heat patterns. The supersonic winds circulating around the planet carry heat away from the day side and distribute it toward the night side. Because of this process, the hottest region of the atmosphere is not directly beneath the star. Instead, it is carried slightly eastward by the powerful winds before the heat can radiate back into space. This observation confirmed that the planet's winds were not just theoretical predictions. They were physically reshaping the planet's climate. These winds are among the fastest ever detected in any planetary atmosphere. Their speed approaches 7,000 kilometers per hour. At such velocities, atmospheric gases behave very differently from the air on Earth. Shockwaves, turbulence, and enormous jet streams dominate the upper atmosphere. The eternal day side, the side of HD 189733b that faces its star, is exposed to constant radiation. Unlike Earth, where the rotation of the planet creates a cycle of day and night, this hemisphere experiences permanent daylight. The intense radiation heats the atmosphere to temperatures exceeding 1,200 degrees Celsius. At these temperatures, the atmospheric gases become extremely energetic. Molecules move rapidly, causing the atmosphere to expand. This expansion drives the powerful winds that carry heat across the planet. The day side is also where mineral vapors are most likely to form. Rocks heated by the extreme environment release silicate compounds into the atmosphere. These vapors eventually condense into the mineral clouds that fill the planet's skies. The dark hemisphere. On the opposite side of the planet lies the permanent night side. This hemisphere never sees the star. Without direct radiation, temperatures are lower than on the day side. However, the night side is still extremely hot by Earth standards. Heat transported by the planet's winds prevents the atmosphere from cooling dramatically. Temperatures remain hundreds of degrees above what we would experience on our planet. Still, the night side plays an important role in the planet's weather. As hot gases move from the day side toward the night side, they gradually cool. This cooling process allows mineral vapors to condense. Particles begin forming within the atmosphere. These particles contribute to the clouds and eventually to the glass storms that sweep across the planet. The boundary between day and night. Between the two hemispheres lies a region known as the terminator. This is the boundary where the day side meets the night side. On Earth, the terminator is simply the moving line between day and night during sunrise and sunset. But on HD 189733b, the terminator is permanent. One side of the boundary faces the star. The other faces deep space. This region experiences enormous temperature gradients. Hot gases from the day side meet cooler atmospheric layers from the night side. The collision of these air masses produces intense turbulence. Many scientists believe that some of the planet's most powerful storms occur near this boundary. It is also one of the most important regions for studying the planet's atmosphere. When HD 189733b transits its star, astronomers observe light passing through the atmosphere near this boundary. That light carries information about the gases and particles present in the atmosphere, detecting the planet's blue color. Another important discovery about HD 189733b came when astronomers studied its reflected light. The planet appears deep blue when viewed in visible wavelengths. This unusual color attracted significant attention because it resembles the appearance of Earth when seen from space. However, the similarity is purely visual. Earth's blue color comes from sunlight scattering in the atmosphere and reflecting off the oceans. HD 189733b has no oceans. Instead, its color comes from tiny particles suspended high in the atmosphere. These particles scatter blue wavelengths of light more effectively than red wavelengths. The effect is similar to the reason Earth's sky appears blue, but the particles responsible for the scattering are completely different. They are made from silicate minerals. These microscopic grains of rock are responsible for both the planet's color and its violent glass storms. Evidence of violent weather. Over time, astronomers began noticing changes in the planet's atmospheric signals. These changes suggested that the atmosphere itself was evolving. Storm systems might grow and dissipate over time. Cloud layers could shift across the planet. The data hinted at a dynamic atmosphere constantly reshaped by the powerful winds. This type of variability is common in planetary atmospheres. On Earth, weather systems change daily, but on HD 189733b, those changes happen under far more extreme conditions. The combination of high temperatures, powerful winds, and mineral clouds creates a climate system unlike anything in our solar system. A planet that is slowly losing its atmosphere. Another discovery added an even more dramatic element to the story of HD 189733b. observations revealed that the planet may be losing parts of its atmosphere into space. Because the planet orbits so close to its star, it receives intense radiation. This radiation heats the upper layers of the atmosphere and causes them to expand. Eventually, some of the gas becomes energetic enough to escape the planet's gravity. Astronomers detected streams of hydrogen gas flowing away from the planet into space. In effect, the star is slowly stripping away portions of the planet's atmosphere. Over millions or billions of years, this process could significantly alter the planet's structure. It may even reduce the size of the planet's atmosphere over time. A dynamic alien climate. By combining observations from multiple telescopes, scientists have constructed a detailed picture of HD 189733b's climate. It is a planet dominated by extremes: permanent daylight on one side, endless darkness on the other, supersonic winds carrying heat around the globe, mineral clouds forming and dissolving in a constantly shifting atmosphere, and storms of glass sweeping across the planet at extraordinary speeds. These discoveries have transformed HD 189733b into one of the most studied exoplanets in astronomy. It is not just a distant curiosity. It is a window into the physics of extreme planetary environments. And it reminds us that the universe is filled with worlds far stranger than anything imagined just a few decades ago. In the next part, we will explore how scientists continue to investigate planets like HD 189733b, and how future telescopes may soon reveal even more extraordinary alien worlds hidden throughout the galaxy. Studying a planet like HD 189733b presents an enormous challenge. The planet lies about 64 light-years from Earth, orbiting a star too distant to ever reach with today's spacecraft. Even our fastest probes would require tens of thousands of years to travel such distances. Yet, despite this enormous gap, scientists have managed to uncover remarkable details about this alien world. They have measured its temperature. They have detected the chemicals in its atmosphere. They have mapped its climate and wind patterns, and they have even determined the color of its sky. All of this knowledge comes from one of the most powerful tools in modern astronomy: light. Every observation astronomers make of distant planets relies on studying the tiny signals hidden within starlight. The discovery of the planet, the story of HD 189733b, began when astronomers were searching for planets outside our solar system. Planets orbiting other stars are known as exoplanets, and finding them is extremely difficult. Unlike stars, planets do not produce their own light. They are usually drowned in the brightness of the stars they orbit. But astronomers discovered a clever method to detect them. If a planet passes directly between its star and Earth, it blocks a tiny fraction of the star's light. This event is known as a transit. By measuring slight dips in a star's brightness, scientists can detect planets that pass in front of it. This technique allowed astronomers to identify HD 189733b in 2005. The discovery immediately attracted attention. The planet's orbit was extremely close to its star, and its large size meant it produced a noticeable dip in the star's light. That made it an ideal target for further study. Measuring the size of the planet. Once astronomers observed the transit of HD 9733b, they could determine the planet's size. The amount of light blocked during the transit reveals how large the planet is compared to its star. For HD 189733b, the measurements showed that the planet is slightly larger than Jupiter. That places it firmly in the category of hot Jupiters, a class of massive gas giants that orbit extremely close to their stars. These planets were once thought to be rare. But after the first discoveries, astronomers realized that the hot Jupiters appear in many planetary systems. Their existence forced scientists to rethink how planets form and migrate within young solar systems. Detecting the planet's atmosphere. Detecting the atmosphere of a distant planet might seem impossible, but the transit method provides a clever solution. When HD 189733b passes in front of its star, some of the star's light filters through the planet's atmosphere before reaching Earth. During this brief moment, molecules in the atmosphere absorb certain wavelengths of light. By analyzing which wavelengths are absorbed, astronomers can identify the chemicals present in the atmosphere. This process is known as transmission spectroscopy. It allows scientists to study the composition of atmospheres on planets that lie dozens or even hundreds of light years away. Using this method, astronomers detected water vapor in the atmosphere of HD 189733b. This was one of the earliest confirmations that water molecules exist in the atmosphere of an exoplanet. The role of space telescopes. Studying distant planets requires extremely precise instruments. Earth's atmosphere interferes with many astronomical observations. So much of the research on HD 189733b has relied on space telescopes. One of the most important instruments used to study the planet was the Hubble Space Telescope. Hubble's powerful instruments allowed astronomers to analyze how light from the star changed during planetary transits. These observations reveal details about the atmosphere that would have been impossible to detect from the ground. Another important tool was the Spitzer Space Telescope. Spitzer was designed to detect infrared radiation, heat emitted by objects in space. Because HD 189733b is extremely hot, it glows brightly in infrared wavelengths. This allowed scientists to measure temperature differences across the planet. By tracking how the infrared signal changed as the planet orbited its star, astronomers constructed the first temperature maps of an exoplanet. Observing a planet's day and night, one of the most remarkable achievements in studying HD 189733b was observing both its day side and night side. This became possible through a phenomenon known as the secondary eclipse. A secondary eclipse occurs when the planet passes behind its star from Earth's point of view. When the planet disappears behind the star, the total light from the system drops slightly. That drop represents the light coming from the planet itself. By measuring this difference, astronomers can determine how much light, and therefore heat, the planet emits. This technique allowed scientists to estimate the temperature of the planet's day side. Later observations measured how heat was distributed across the planet as it orbited its star. These measurements revealed the powerful winds transporting heat across the atmosphere. Detecting atmospheric escape. Another discovery about HD 9733b came when astronomers studied ultraviolet light from the system. These observations revealed something dramatic. The planet's atmosphere appeared to be escaping into space. Intense radiation from the star heats the outer layers of the atmosphere. When the gas becomes hot enough, it can escape the planet's gravitational pull. This creates a stream of particles flowing away from the planet. Astronomers detected hydrogen gas forming a cloud around the planet. Some of this gas stretches far beyond the planet itself, forming a tail similar to that of a comet. Over time, this process could gradually strip away parts of the planet's atmosphere. A star that influences the planet. The extreme environment of HD 18973b is closely tied to the behavior of its star. The star itself is smaller and slightly cooler than our Sun, but the planet's close orbit exposes it to intense radiation. Occasionally, the star releases powerful bursts of energy known as stellar flares. When these flares occur, the radiation hitting the planet increases dramatically. Astronomers observed one such flare and noticed that the planet's atmosphere responded almost immediately. The flare heated the upper atmosphere and accelerated the escape of hydrogen gas into space. This observation provided direct evidence that stellar activity can influence the evolution of planetary atmospheres. Learning about alien weather. Every observation of HD 189733b adds to our understanding of planetary atmospheres. The planet has become one of the best natural laboratories for studying atmospheric physics. Its extreme conditions allow scientists to observe processes that are difficult to detect elsewhere. For example, the interaction between intense radiation and atmospheric chemistry can be studied in detail. The behavior of supersonic winds across a tidally locked planet provides insights into atmospheric circulation. And the presence of mineral clouds helps researchers understand how different materials behave in exotic planetary environments. These studies help refine the models used to predict climates on distant worlds, a window into other planetary systems. Perhaps the most important reason scientists study HD 189733b is that it represents just one example of the enormous diversity of planets in our galaxy. Before the discovery of exoplanets, astronomers assumed most planetary systems would resemble our own. But observations have revealed thousands of planets with wildly different environments. Some are giant gas planets orbiting extremely close to their stars. Others are rocky worlds larger than Earth. Some orbit 2 stars instead of 1. Others may contain oceans of water beneath thick ice layers. Each discovery expands our understanding of what planets can be. HD 189733b, with its glass storms and supersonic winds, is one of the most dramatic examples. A planet revealed through light. What makes the story of HD 189733b so remarkable is not only the planet itself, but also the ingenuity used to study it. Scientists cannot travel to this world. They cannot send spacecraft to photograph its storms. Yet by studying tiny variations in light, astronomers have uncovered a detailed picture of a planet orbiting far beyond our solar system. They have revealed its atmosphere. They have mapped its temperatures. They have detected its violent winds. And they have discovered one of the strangest weather systems ever imagined: storms of glass moving at thousands of kilometers per hour. All of this knowledge comes from carefully interpreting the faint signals carried by starlight across 64 light-years of space. In the next part, we will explore how planets like HD 189733b compare to other extreme worlds, and how the discovery of such planets is reshaping our understanding of the universe itself. When scientists first began discovering planets beyond our solar system, many expected those systems to resemble our own. Small rocky planets near their stars, gas giants orbiting far away, and calm, stable environments where planetary climates evolved slowly over time. But the discovery of HD 189733b forced astronomers to rethink those assumptions. This distant world showed that planets could exist in environments far more extreme than anything in our own solar system. And once scientists began looking more closely, they realized something even more surprising. HD 189733b was not unique. It was just one example of a vast population of strange planets scattered across the galaxy. The rise of exoplanet discovery. For most of human history, the idea of planets around other stars was purely theoretical. Astronomers suspected they existed, but they had no direct evidence. That changed in the 1990s, when the first confirmed exoplanets were discovered. Since then, thousands of planets have been detected orbiting distant stars. Many of these discoveries were made using space telescopes designed specifically to search for planetary transits. One of the most successful missions was the Kepler Space Telescope. Launched in 2009, Kepler monitored the brightness of over 150,000 stars. Its goal was simple: detect the tiny dips in brightness caused by planets passing in front of their stars. Over the course of its mission, Kepler discovered thousands of candidate planets. Many of them were unlike anything previously imagined. The diversity of alien worlds. As more planets were discovered, astronomers began categorizing them based on their properties. Some were small rocky planets similar to Earth. Others were massive gas giants larger than Jupiter. But many fell into entirely new categories. There are super-Earths, rocky planets several times the size of our own. There are mini-Neptunes, worlds with thick atmospheres, but smaller than Neptune. Some planets orbit so close to their stars that their surfaces are likely covered in oceans of molten lava. Others orbit so far away that their atmospheres may be permanently frozen. And then there are the hot Jupiters. These massive gas giants orbit extremely close to their stars, often completing an orbit in just a few days. HD 189733b is one of the most famous examples of this class of planets. Why hot Jupiters matter? Hot Jupiters were among the first exoplanets ever discovered. That is partly because they are easier to detect. Their large size blocks more light when they pass in front of their stars. Their strong gravity causes noticeable wobbles in the motion of their stars, but their existence also revealed something unexpected. Gas giants were not supposed to form close to their stars. The intense heat should prevent the accumulation of large gas envelopes. This led scientists to conclude that hot Jupiters likely form far from their stars before migrating inward. Understanding this process became an important goal for astronomers studying planetary formation. HD 189733b provided one of the best opportunities to investigate these theories. A planet perfect for observation. One reason HD 189733b became so important in astronomy is that it is relatively close to Earth. At a distance of about 64 light years, it is one of the nearest known transiting exoplanets. This proximity allows telescopes to collect more detailed data than would be possible for more distant worlds. The planet's frequent transits also make it easier to observe. Because it orbits its star every 2.2 days, astronomers can observe many transits in a short period of time. Each transit provides new information about the planet's atmosphere. Each orbit allows scientists to study how heat moves across the planet. These repeated observations have made HD 189733b one of the most well-studied exoplanets in history. The challenge of observing alien atmospheres. Studying the atmosphere of an exoplanet is one of the most difficult tasks in astronomy. Even the largest planets appear as tiny points of light when observed from Earth. Their atmospheres cannot be photographed directly. Instead, astronomers must analyze how light interacts with the planet's atmosphere. This requires extremely sensitive instruments capable of detecting minute variations in brightness. Space telescopes like the Hubble Space Telescope have been crucial in this work. By studying the light passing through the atmosphere during planetary transits, scientists can identify the chemical signatures of various molecules. For HD 189733b, these observations revealed the presence of water vapor, methane, and other gases. But the most striking discovery was the presence of silicate particles that form the planet's mineral clouds. The importance of extreme planets like HD 189733b provide valuable opportunities for scientists to test theories about atmospheric physics. Extreme environments often reveal processes that are difficult to observe under more moderate conditions. For example, the planet's intense heat allows scientists to study how minerals behave in gaseous form. The supersonic winds reveal how atmospheric circulation works when temperature differences become extreme. Even the planet's glass storms offer insights into how particles interact with powerful atmospheric currents. These discoveries help scientists develop better models of planetary atmospheres. Those models can then be applied to other exoplanets, including worlds that may have more Earth-like environments. The next generation of telescopes, while HD 189733b has already provided valuable insights, future telescopes promise to reveal even more details about distant planets. One of the most powerful instruments currently in operation is the James Webb Space Telescope. The James Webb Telescope was designed to observe the universe in infrared wavelengths. This makes it particularly useful for studying the atmospheres of exoplanets. Infrared light carries information about heat, molecular composition, and atmospheric structure. With its advanced instruments, James Webb can analyze the atmospheres of planets in unprecedented detail. Scientists expect that observations from this telescope will reveal new molecules, new cloud structures, and perhaps even unexpected atmospheric processes. Planets like HD 189733b are ideal targets for these observations, searching for habitable worlds. While HD 189733b is far too hostile to support life, studying such extreme planets helps scientists refine the techniques used to search for habitable worlds. Detecting the atmosphere of a distant planet requires extremely precise measurements. The same methods used to study HD 189733b can be applied to smaller, cooler planets. If astronomers detect gases such as oxygen, methane, or water vapor in the atmosphere of an Earth-sized planet, it could indicate conditions suitable for life. Future telescopes may even be able to identify chemical signatures that suggest biological activity. In this way, the study of extreme worlds contributes directly to one of the greatest scientific questions of all time. Are we alone in the universe? A universe full of strange worlds. The discovery of HD 189733b and other exoplanets has transformed our understanding of the cosmos. Instead of a universe filled with planetary systems similar to our own, we now know that the galaxy contains an incredible diversity of worlds. Some planets are hotter than molten metal. Others may contain oceans beneath thick layers of ice. Some may wander through space without orbiting any star at all. Each new discovery expands the boundaries of what scientists thought possible. And with every observation, astronomers move closer to understanding how planets form, evolve, and interact with their stars. HD 189733b is just one world among billions, but its violent storms, mineral clouds, and glass rain have made it one of the most fascinating planets ever discovered. In the next part, we will explore what it might actually be like to visit such a world, and why surviving even a few moments in its atmosphere would be nearly impossible. By now, astronomers have learned an extraordinary amount about HD 189733b. They have measured its orbit, analyzed its atmosphere, mapped its temperatures, and even detected its violent glass storms. But this leads to a fascinating question. What would actually happen if we tried to visit such a world? Of course, traveling to HD 189733b is far beyond our current technological capabilities. The planet lies 64 light-years away, and even our fastest spacecraft would require tens of thousands of years to reach it. Still, imagining such a journey helps scientists understand just how extreme this alien environment really is. If a probe ever arrived there, it would encounter one of the most hostile climates known anywhere in the universe. Approaching the planet. Long before reaching the atmosphere, a spacecraft approaching HD 189733b would notice something unusual. Unlike Earth or Mars, the planet does not reflect sunlight in familiar ways. Instead, the world appears as a deep blue sphere orbiting extremely close to its star. At first glance, it might even look peaceful, but that blue color hides a violent truth. The planet's atmosphere is filled with microscopic mineral particles. These particles scatter blue wavelengths of light, giving the planet its unusual appearance. But those same particles eventually form the razor-sharp fragments that fall as glass rain. As the spacecraft approaches the planet, it would begin detecting enormous radiation levels coming from the nearby star. Because the planet orbits so close to its star, it is constantly exposed to intense stellar energy. This radiation heats the atmosphere and powers the planet's violent climate. Entering the upper atmosphere. If a probe attempted to descend into the atmosphere of HD 189733b, the first obstacle would be temperature. The upper atmosphere already exceeds 1000 degrees Celsius. That is hot enough to melt many metals used in spacecraft construction. Any probe entering the atmosphere would require materials capable of surviving extreme heat. But temperature would only be the beginning. The probe would also encounter winds moving at incredible speeds. Atmospheric circulation on this planet drives winds approaching 7,000 kilometers per hour. That is faster than most bullets. For comparison, the most powerful hurricanes on Earth rarely exceed 300 kilometers per hour. On HD 189733b, the winds are more than 20 times stronger. These winds would buffet any spacecraft violently, making controlled descent extremely difficult. The storms of glass. As the probe descended deeper into the atmosphere, it would begin encountering one of the most dangerous features of the planet's climate: glass storms. The clouds of HD 189733b are made of silicate particles, minerals composed of silicon and oxygen. These particles form when vaporized rock cools in the upper atmosphere. Eventually, they condense into tiny grains. Those grains are then carried through the atmosphere by powerful winds. As they collide and grow larger, they begin falling. But instead of falling vertically like rain on Earth, they are swept sideways by the planet's extreme winds. The result is a storm of microscopic glass fragments moving across the atmosphere at thousands of kilometers per hour. Any spacecraft caught in such a storm would be bombarded continuously by sharp particles traveling at incredible speeds. Even the toughest materials would gradually erode under such conditions. A planet without solid ground. Another problem facing any potential probe is that HD 189733b does not have a solid surface like Earth. The planet is a gas giant, similar in structure to Jupiter. This means the atmosphere gradually becomes denser as one moves deeper into the planet. Instead of landing on solid ground, a spacecraft would continue descending into thicker and thicker layers of gas. Pressure would increase dramatically. Eventually, the pressure would become so intense that the spacecraft structure would collapse. Even on Jupiter, probes can survive only for a short time before being crushed by the enormous atmospheric pressure. On HD 189733b, the combination of heat, pressure, and violent winds would make survival even more difficult. The crushing depths. As a probe descended further into the atmosphere, the pressure would rise rapidly. In gas giants, pressure increases dramatically with depth. Within a relatively short distance, the atmospheric pressure could become hundreds or thousands of times stronger than Earth's surface pressure. Under such conditions, gases behave very differently. Hydrogen and helium, the main components of the planet's atmosphere, begin compressing into exotic forms. Deeper still, the pressure may become strong enough to create liquid metallic hydrogen. This strange substance behaves like a liquid metal and conducts electricity extremely well. It is believed to exist deep within large gas giants like Jupiter. Although scientists cannot observe this layer directly on HD 1897333b, theoretical models suggest that similar conditions may exist inside the planet. The planet's magnetic environment. If HD 1897333b contains layers of metallic hydrogen deep inside, it may generate a powerful magnetic field. Gas giants in our own solar system produce strong magnetic fields because of the movement of electrically conductive fluids inside their interiors. For example, Jupiter has one of the strongest magnetic fields among the planets. A similar process could occur on HD 1897333b. If the planet generates a strong magnetic field, it would interact with the powerful radiation coming from its nearby star. These interactions could produce intense auroras in the planet's atmosphere. Auroras are glowing light displays caused by charged particles colliding with atmospheric gases. On Earth, they appear as the northern and southern lights. On HD 1897333b, they might be far more dramatic, possibly covering large portions of the sky. The permanent day. Side. One of the most unusual aspects of HD 1897333b is its tidal locking. Because the planet orbits extremely close to its star, gravitational forces have synchronized its rotation. One side of the planet always faces the star. The other side remains in permanent darkness. This creates two radically different environments. On the day side, temperatures soar above 1,200 degrees Celsius. The sky would glow with intense radiation from the nearby star. Minerals vaporize in the atmosphere, feeding the formation of silicate clouds. Meanwhile, the night side receives no direct starlight. Temperatures are lower, though still far hotter than anything on Earth. The difference between these two hemispheres drives the supersonic winds that sweep across the planet. The planet's host, star. The extreme climate of HD 1897333b is closely connected to the behavior of its parent star. The star itself is slightly smaller and cooler than our Sun, but the planet's proximity exposes it to intense radiation. Because the planet orbits so close to the star, it experiences powerful bursts of stellar energy. These bursts, known as stellar flares, release enormous amounts of radiation. When such flares occur, the planet's atmosphere absorbs the energy almost immediately. Astronomers have observed that these flares can dramatically increase the rate at which the planet's atmosphere escapes into space. Streams of hydrogen gas flow away from the planet, forming a cloud that trails behind it. Over long periods of time, this process may gradually erode the planet's atmosphere. Why this planet fascinates scientists. Despite its hostile conditions, HD 1897333b has become one of the most important exoplanets in astronomy. Its frequent transits and relative proximity make it easier to study than many other distant worlds. Because of this, scientists have been able to gather detailed information about its atmosphere, weather systems, and chemistry. The planet serves as a natural laboratory for studying extreme climates. By observing HD 1897333b, astronomers learn how atmospheres behave under intense heat, powerful winds, and strong stellar radiation. These insights help improve the models used to study other planets across the galaxy. Some of those planets may be far more hospitable than this violent world. A world humans could never survive. If humans could somehow travel to HD 189733b, survival would be impossible. The heat alone would destroy any conventional spacecraft. The winds would tear apart fragile structures. The glass storms would erode exposed surfaces, and the crushing pressure of the deeper atmosphere would eventually collapse even the strongest materials. This planet is a reminder that most worlds in the universe are not friendly places. Many are far more extreme than anything found in our own solar system. Yet studying these hostile environments helps scientists understand the incredible diversity of planets scattered across the galaxy. And every new discovery brings us closer to answering one of humanity's greatest questions. What other strange worlds are waiting to be discovered among the stars? The discovery of HD 189733b revealed something astonishing about the universe. Planets can exist in environments far more extreme than anything we once imagined. A world where storms hurl shards of glass through the atmosphere at 7,000 kilometers per hour seemed almost impossible when it was first proposed. Yet today, HD 189733b is one of the most well-studied planets beyond our solar system. But as astronomers continued exploring the galaxy, they discovered something even more surprising. HD 189733 is not the strangest world we know. In fact, the universe appears to be filled with planets whose environments challenge everything we thought we understood about planetary science. Lava oceans and molten worlds. Some exoplanets orbit so close to their stars that their surfaces are permanently molten. One dramatic example is 55 Cancri e. This rocky planet orbits its star in just 18 hours, making it one of the fastest orbiting planets ever discovered. At such close distances, the surface temperature exceeds 2,000 degrees Celsius. That is hot enough to melt rock. Scientists believe the planet may be covered in vast oceans of molten lava. Volcanoes may erupt constantly across the surface, releasing clouds of vaporized minerals into the atmosphere. These vapors may later cool and fall back toward the surface as mineral rain. In some ways, this environment is even more extreme than HD 189733b. Instead of glass storms moving through the sky, entire landscapes may flow like oceans of fire. A planet made of diamond. Another extraordinary discovery came when astronomers studied PSRB 1257 plus 12b, a world orbiting a pulsar. Pulsars are the collapsed remnants of massive stars that exploded as supernovae. They emit powerful beams of radiation that sweep through space like cosmic lighthouses. Despite the harsh radiation environment, planets can still orbit these exotic stars. One of these planets may contain enormous quantities of carbon compressed under extreme pressure. Some scientists believe that much of its interior may consist of crystallized carbon, essentially forming a giant diamond. If this interpretation is correct, the planet could contain diamond layers thousands of kilometers thick. It is a reminder that planetary chemistry can produce worlds far stranger than anything found in our own solar system. A planet where it rains iron. Another exotic world discovered by astronomers is WASP 76b. Like HD 189733b, this planet is a hot Jupiter orbiting extremely close to its star. But the temperatures here are even more extreme. On the planet's day side, temperatures exceed 2,400 degrees Celsius. At these temperatures, iron can vaporize. That means the atmosphere contains clouds made of iron vapor. As powerful winds carry this vapor toward the cooler night side of the planet, the iron condenses. The result is something almost unimaginable: rain made of molten iron. Just like water vapor condenses into raindrops on Earth, iron vapor condenses into droplets that fall through the planet's atmosphere. This phenomenon shows how different planetary weather can become under extreme temperatures. A planet that orbits two stars. Some planets exist in even stranger orbital environments. For example, Kepler 16b orbits two stars instead of one. These planets are known as circumbinary planets. From the surface of such a world, two suns would rise and set in the sky. The gravitational interaction between the stars creates complex orbital patterns. Day and night cycles may vary depending on how the stars move relative to the planet. While HD 189733b has violent weather, circumbinary planets demonstrate how unusual planetary systems can become. The universe is capable of building planetary environments that seem almost like science fiction. The coldest known worlds. Not all strange planets are extremely hot. Some exist in environments so cold that their atmospheres may freeze solid. One example is OGL E-2005-BLG-390LB. This distant planet orbits far from its star, receiving very little heat. Surface temperatures may fall below -220 degrees Celsius. At such low temperatures, the atmosphere could collapse into frozen layers on the surface. Any oceans that might exist would likely be buried beneath thick ice shells. Despite these harsh conditions, some scientists believe that internal heat could still allow liquid water to exist beneath the surface. These frozen worlds show that planetary environments can vary dramatically depending on their distance from their stars. Why extreme worlds matter. At first glance, studying these hostile planets might seem purely academic. After all, none of them could support life as we know it. But extreme planets play an important role in planetary science. They allow researchers to test theories about how planets form and evolve. For example, hot Jupiters, like HD 189733b, help scientists understand planetary migration. Molten worlds like 55 Cancri EE reveal how rocky planets behave under intense heat. Iron rain planets like WASP 76b demonstrate how atmospheric chemistry changes at extremely high temperatures. Each discovery helps refine our models of planetary systems, and those models can then be applied to planets that may be far more hospitable. Searching for Earth-like planets. While astronomers study extreme worlds, they are also searching for planets that resemble Earth. One of the most promising discoveries in this search is Kepler 452b. This planet orbits within the habitable zone of its star, the region where temperatures may allow liquid water to exist. Liquid water is considered one of the most important ingredients for life. Planets within the habitable zone are therefore prime targets for future observations. Scientists hope that studying these worlds may eventually reveal signs of biological activity. Detecting such evidence would represent one of the most important discoveries in human history. The role of new telescopes. The search for habitable planets is accelerating thanks to new technology. One of the most powerful instruments currently operating is the James Webb Space Telescope. This telescope allows astronomers to analyze the atmospheres of distant planets in unprecedented detail. By studying the chemical composition of these atmospheres, scientists can detect gases such as water vapor, methane, or carbon dioxide. In some cases, the presence of certain combinations of gases could suggest biological processes. Future telescopes may go even further. Projects currently under development aim to directly image Earth-like planets orbiting nearby stars. These observations could allow scientists to study the surfaces and atmospheres of distant worlds in ways never before possible. A universe of endless variety. The more planets astronomers discover, the more they realize that our solar system may not represent the typical planetary system in the galaxy. Instead of calm, orderly environments, the universe appears filled with incredible diversity. Planets with molten oceans, planets where metal rains from the sky, planets with diamond interiors, planets orbiting two stars, and planets like HD 1-89733b, where violent winds drive storms of glass across a scorching atmosphere. Each discovery expands our understanding of what planets can be, and with every new telescope and every new observation, astronomers move closer to understanding how common or rare Earth-like worlds might be. Because somewhere among the billions of stars in our galaxy, there may be a planet where the conditions are just right for life to exist. In the next part, we will explore how future missions and technologies could allow scientists to study distant planets in even greater detail, and perhaps one day reveal signs of life beyond our solar system. For centuries, humans looked up at the night sky and wondered whether planets existed around other stars. Today, astronomers know that the galaxy is filled with them. More than 5,000 exoplanets have already been discovered, and thousands more candidates continue to appear as telescopes collect new data. Among those discoveries, HD 1-89733b remains one of the most fascinating examples of how extreme alien worlds can be. A planet where winds reach thousands of kilometers per hour, a planet where mineral clouds fill the sky, and a planet where storms may carry shards of glass across its atmosphere. Yet despite everything astronomers have already learned, the truth is that our understanding of such planets is still only beginning, because the next generation of telescopes is about to change everything. The limits of current observations. Even with powerful observatories, studying distant planets remains extremely difficult. Most exoplanets cannot be seen directly. They are too small and too faint compared to the stars they orbit. A star can be billions of times brighter than the planets surrounding it. That overwhelming brightness makes it nearly impossible to photograph the planets themselves. Instead, astronomers rely on indirect methods. They watch for the slight dimming of starlight during planetary transits. They measure tiny wobbles in a star's motion caused by gravitational interactions with orbiting planets. They analyze subtle changes in light passing through planetary atmospheres. These techniques have revealed extraordinary information about worlds like HD 189733b, but they also have limitations. To truly understand distant planets, scientists need better instruments. A new era of space telescopes. One of the most powerful tools currently studying exoplanets is the James Webb Space Telescope. Launched in 2021, this telescope was designed to observe the universe in infrared wavelengths. Infrared light is particularly useful for studying planetary atmospheres. Heat emitted by planets appears strongly in infrared wavelengths. This allows astronomers to detect molecules such as water vapor, carbon dioxide, and methane. The James Webb Telescope has already begun analyzing the atmospheres of several exoplanets. These observations provide far more detailed data than previous telescopes could obtain. For planets like HD 189733b, this means scientists can examine the atmosphere with unprecedented precision. They can detect new chemical compounds. They can study cloud structures, and they can investigate how heat moves across the planet. The search for atmospheric chemistry. One of the most important goals of exoplanet research is understanding atmospheric chemistry. The atmosphere of a planet can reveal an enormous amount about its environment. For example, the presence of water vapor suggests that water exists somewhere within the system. Carbon dioxide indicates geological or atmospheric processes. Methane may be produced by geological activity or possibly biological processes. By analyzing atmospheric spectra, scientists can determine which molecules are present. This technique has already revealed water vapor in the atmosphere of HD 189733b. Future observations may detect additional molecules and refine our understanding of the planet's climate. Such discoveries help astronomers build detailed models of how alien atmospheres behave. Directly photographing exoplanets. While most exoplanets are detected indirectly, astronomers are also developing methods to photograph them directly. This is extremely difficult because of the brightness of the host stars. However, special instruments called coronagraphs can block out the star's light, allowing nearby planets to become visible. Using this technique, astronomers have already captured images of several giant exoplanets. These planets are typically young and located far from their stars, making them easier to observe. But future telescopes may be able to image smaller planets closer to their stars. Such images would provide an entirely new way to study planetary systems. Instead of inferring the existence of planets through indirect measurements, scientists could observe them directly. The next generation of giant observatories. Several new telescopes currently under development promise to revolutionize exoplanet research. One example is the Extremely Large Telescope. This massive telescope is being built in Chile and will have a mirror nearly 40 meters wide. Its enormous size will allow it to collect far more light than existing telescopes. That increased sensitivity will enable astronomers to study smaller and more distant planets. Another important project is the Nancy Grace Roman Space Telescope. This telescope will include advanced coronagraph technology designed specifically for exoplanet imaging. It may be capable of directly observing planets that were previously impossible to detect. Together, these new observatories will dramatically expand our ability to study alien worlds. detecting signs of life. Perhaps the most exciting possibility in exoplanet research is the search for life. Astronomers believe that certain combinations of atmospheric gases could indicate biological activity. For example, on Earth, the simultaneous presence of oxygen and methane is largely produced by living organisms. Without life constantly replenishing these gases, they would react with each other and disappear. If scientists detected a similar chemical imbalance in the atmosphere of a distant planet, it could suggest the presence of life. Detecting such signals requires extremely precise measurements. Future telescopes may eventually reach the sensitivity needed to identify these biosignatures. If that happens, it would represent one of the most profound discoveries in human history. Why extreme planets help the search? Although HD 189733b is far too hostile for life, studying such extreme planets helps scientists improve the techniques used to analyze atmospheres. Hot Jupiters provide strong signals that are easier to detect than smaller planets. Their large atmospheres allow astronomers to test new observational methods. Every observation improves our understanding of how to interpret atmospheric data. This knowledge can then be applied to smaller, cooler planets that may be more hospitable. In this way, even the most violent worlds contribute to the search for life elsewhere in the universe. The possibility of Earth-like worlds. The discovery of Earth-sized planets in the habitable zones of their stars has already begun. One example is Kepler 186f. This planet orbits within the region around its star where temperatures may allow liquid water to exist. Liquid water is considered one of the key ingredients for life. While we do not yet know whether Kepler 186f has an atmosphere or oceans, its discovery demonstrates that Earth-sized planets exist around other stars. As telescopes become more powerful, scientists expect to find many more such worlds. Some of them may lie relatively close to Earth, and one day, astronomers may detect clear signs that life exists on one of them. A future of discovery. The story of exoplanets is still in its early stages. Just a few decades ago, scientists had never confirmed the existence of a single planet beyond our solar system. Today, thousands are known. Some worlds are covered in lava. Others may rain molten metal. Some may contain deep oceans hidden beneath frozen crusts. And others, like HD 189733b, experience storms of glass moving at incredible speeds. Each discovery reveals something new about the complexity of planetary systems. Each observation expands our understanding of the universe. And with the next generation of telescopes, humanity is about to explore alien worlds in ways that were once impossible. In the final part, we will step back and consider what planets like HD 189733b ultimately teach us about our place in the universe, and why the search for other worlds has become one of the most exciting scientific journeys of our time. In the vast darkness of space, scattered among billions of stars, countless planets orbit silently. Some are cold and distant, locked in eternal darkness. Others are scorched by their stars, their atmospheres boiling under relentless radiation. Among these strange worlds lies one of the most dramatic examples ever discovered, HD 189733b. a planet where the winds roar faster than the speed of sound, a planet where clouds are made of vaporized rock, and a planet where storms may hurl shards of glass through the atmosphere at 7,000 kilometers per hour. But the importance of HD 189733b goes far beyond its violent weather. This world has helped scientists rethink how planets form, how atmospheres behave, and how diverse planetary systems across the galaxy truly are. A universe more strange than expected. Before the discovery of exoplanets, astronomers assumed that most planetary systems would resemble our own. Small rocky planets near the star, gas giants farther away, stable orbits and relatively predictable climates. But discoveries over the past few decades have shattered that assumption. Instead, the universe has revealed an astonishing variety of planetary environments. Some planets orbit their stars in just a few hours. Others travel on extremely elongated paths that carry them from freezing darkness into intense heat. Some planets may have entire oceans of molten rock. Others could contain global layers of ice kilometers thick. The discovery of HD 189733b helped scientists realize that planetary systems are far more complex than once imagined. The importance of hot Jupiters. Planets like HD 189733b belong to a category known as hot Jupiters. These are massive gas giants that orbit extremely close to their stars. At first, astronomers were puzzled by their existence. Gas giants were expected to form far from their stars, where temperatures are low enough for large amounts of gas to accumulate. Yet hot Jupiters appear incredibly close to their stars. This suggests that these planets did not form where they currently orbit. Instead, they likely formed farther away and later migrated inward. Understanding this process has become one of the major challenges in planetary science. By studying hot Jupiters like HD 189733b, astronomers have gained valuable insights into how planetary systems evolve. Atmospheres. Under extreme conditions, the atmosphere of HD 189733b has also become an important laboratory for studying planetary climate. Extreme temperatures and intense radiation create conditions rarely seen elsewhere. Under these conditions, familiar materials behave in unusual ways. Minerals that form rocks on Earth can evaporate into gas. Those vapors can condense into tiny particles high in the atmosphere, and when those particles grow larger, they may fall as storms of glass. Such phenomena reveal how atmospheric chemistry can change dramatically depending on temperature, pressure, and radiation. Studying these environments helps scientists develop models that apply to many different types of planets. Learning from alien weather. Weather on Earth may seem powerful. Hurricanes can generate enormous waves and devastating winds. Thunderstorms can produce lightning powerful enough to split trees. But compared to the atmosphere of HD 189733b, Earth's storms are relatively mild. The winds on this distant world may reach 7,000 kilometers per hour. Entire atmospheric systems can circle the planet in a matter of hours. Mineral clouds swirl through the sky, while temperatures remain hot enough to melt many metals. Studying these extreme weather patterns helps scientists understand how atmospheres behave under intense conditions. Those lessons can then be applied to other planets across the galaxy. The role of advanced telescopes. Much of what we know about HD 189733b has come from observations made by powerful space telescopes. One of the most important instruments in this research is the James Webb Space Telescope. With its advanced infrared sensors, this telescope can analyze the chemical composition of distant planetary atmospheres. By studying the light that passes through these atmospheres, scientists can detect molecules such as water vapor, methane, and carbon dioxide. These discoveries help reveal how alien climates operate. Future telescopes may go even further, allowing astronomers to detect even more subtle chemical signatures. The search for habitable worlds. Although HD 189733b is far too hostile for life, studying such extreme planets helps astronomers refine the techniques used to search for habitable worlds. Detecting the atmosphere of a distant planet requires extremely precise measurements. Hot Jupiters provide strong signals that make them easier to analyze. By studying these planets, scientists learn how to interpret atmospheric data more accurately. Those same methods can then be applied to smaller planets that may have conditions suitable for life. Among the most exciting discoveries are planets that orbit within the habitable zone of their stars. One example is Kepler 452b. This planet orbits at a distance where temperatures may allow liquid water to exist on the surface. While scientists do not yet know whether it has oceans or an atmosphere similar to Earth's, its discovery shows that Earth-like worlds may be common in the galaxy. A galaxy filled with planets. The Milky Way galaxy contains roughly 100 billion stars. If even a small fraction of those stars have planets, then the number of planets in our galaxy alone could reach hundreds of billions. Many of those worlds may be completely different from anything we have ever seen. Some may resemble HD 189733b, with violent storms and extreme temperatures. Others may be frozen worlds orbiting faint stars, and somewhere among them, there may be planets with conditions similar to Earth. Worlds with oceans, clouds, and perhaps even life. The discovery of HD 189733b reminds us that the universe is far more diverse than we once believed. Humanity's expanding perspective. Just a few decades ago, scientists had never confirmed the existence of a single planet outside our solar system. Today, thousands of exoplanets have been discovered. Each new world adds another piece to the puzzle of how planetary systems form and evolve. HD 189733b is one of the planets that helped open this new chapter in astronomy. Its extreme climate forced scientists to reconsider what planetary environments could look like. It showed that atmospheres could behave in ways never before observed, and it demonstrated that even the most distant worlds can be studied using the faint signals carried by starlight. A violent world in a quiet universe. From a distance, HD 189733b might appear as nothing more than a tiny blue dot orbiting its star, but beneath that appearance lies one of the most violent climates ever discovered. Supersonic winds sweep across the planet. Mineral clouds fill the sky, and storms of glass race through the atmosphere at incredible speeds. It is a world that humans will likely never visit. Yet through the power of science and observation, we have managed to understand its environment from across 64 light-years of space, and that achievement reveals something remarkable about humanity itself. Our ability to explore the universe does not depend only on traveling through space. Sometimes, all it takes is a beam of starlight and the curiosity to understand what secrets it carries across the cosmos.